Okay, we're reviewing for the hardest trig test of the year. So there's no doubt there is going to be some difficult problems, and we'll practice some difficult problems today. Don't let that get you down. If you think of it this way, the R2s are not that bad on this test. Okay, you can get a C on the test easy, and then all you have to do is look at your 4 R3s. Of your 4 R3 questions, you're going to need to get, well, one of them right doesn't really help much, but if you can get 2 of the 4 right, you have a B. Okay, so if you get hit with some problems you don't know how to do, you can still get a B on this test. All right, if there's only one problem you don't know how to do, of course, you'll be able to get an A. All right, so just don't stress out. We're trying to show you a lot of hard problems. If I only showed you the 8 questions that were on the test, and you know that's not fair. I can't do that. But I've got to show you a lot of problems, and some are hard ones that you won't be able to handle, and some will be on the test, and some won't be on the test. So, all right, just don't get stressed when you hit hard problems. There's supposed to be hard problems on there. All right, let me get into the lesson a bit here. Okay, so first of all, I want to go through some of the identities that you have to know. So here is one of them. Cosine of theta. There are several things you could put in instead of cosine theta. Write down a few for me. So if you're in the middle of a problem and you see a cosine, you can replace that with a few things. There's always a 1 over, right? All right, here we go. Cosine, you could have said 1 over secant. And depending on the problem, that might have helped a lot. Because what if there was a secant right next to it? In other words, what if in the problem it was cosine theta times secant theta? You go, oh, cosine is really 1 over secant. You put in that 1 over secant, and then everything just cancels out. Cool. It turns out to be 1. That'll be an example of how you might use that one. All right, so how about anything else? Cosine, is there anything else that cosine is? What? All right, sine minus 1. That's a really common answer, and it only works if they're squared. So that one isn't what we were looking for, because this isn't a cosine squared. That only works for this guy. This is the one you were thinking of. So if you move this to the other side, it'd be 1 minus sine squared theta. Cosine squared is equal to 1 minus sine squared. All right. Anything else that cosine is? Well, you got to go through a few other kinds. Yes? All right. Here's the thing that I think you were thinking of. You remember that? These are called the odd evens. Pay attention now. Cosine of negative x is equal to negative cosine of x. Nope, that's the one where you don't have a negative. Do you remember me telling you that all of these have a negative in them except the 1? All right, so this is the one right here. This is the glaring empty spot where there is no negative there. And the reason is because cosine, if you make it a negative angle versus a positive angle, you actually get the same thing. You get normal cosine of x, whether you do it this way or this way. Because cosine, all students take calc, cosine is positive here and here. All right. So anyway, I think what you were trying to use is that, but the problem is this one doesn't have a negative angle. So it's not a great place to use this one. Yes? Got another one for cosine? Go ahead. Sine of pi over 2 minus theta. You are exactly right, because cosine and sine are what are called cofunctions. Remember that one? All right. I'm going to give you a different one. Let's go with secant. No, let's go with secant squared theta. Give me a few things you could substitute in for that. Notice I used a squared one now. So now you could use some Pythagorean things. You can still do the 1 over stuff. All right, I'm hoping you came up with secant is 1 over cosine. So cosine squared theta would be good. Okay, another one is the 1 with the tan is what we seek. So is secant squared actually equal to this? Yes, it is. It's one of those facts. So 1 plus tangent squared. Think of any others? Some kids surprised me with stuff I didn't think of, but I think that's it. Yes? No, the cofunctions don't work when they're squared. But thank you for trying. All right, so let's go with a different kind. Let's talk about factoring. We need to have a lot of mad factoring skills. So let's try this. I'm going to go back in time to this and see if it helps you with the next problem. How do you factor that? X plus 4, x minus 4. Good. So what if it was cosine squared x minus 16? What would that be? Cosine plus 4 minus 4. All right. That's not likely to happen, but this kind is. Factor that one. 1 is a perfect square just like all those others. 16 and 25 and 81. Cosine x plus 1 minus 1. Now, why would you ever use that? Well, a couple of reasons. First of all, if this was set equal to 0, then this is equal to 0, and then you just have to set that equal to 0 and that equal to 0. This is a classic setup. You get these two factors going where this thing times this thing equals 0, and you're all set up for solving the equation. And you got to find one on this side and one on that side. This one's cosine x plus 1 equals 0. Cosine x equals negative 1. And remember, cosine is the x, right? Sine y, cosine x. If the x is negative 1, is there any spots where x is negative 1 on the circle? Where's x negative 1? Over here. And what is that? Pi. Yep. So the answer for that one's pi. Is there any other place where x is negative 1? Look on here. Is there any other place where x is negative 1? Nope. There's only one answer for that one. And then over here, cosine x minus 1 equals 0. So I'm going to add 1 to both sides. Cosine x equals 1. Where is x equal to 1? Is there more than one answer for that one? No. X is equal to 1 right there. And so the answer is 2 pi. True or false? False. Don't use 2 pi. What is it? Just listen. What is the answer you should use for that one? 0. Why? Because there's a danger that in the directions they would have said, find all the answers between 0 and 2 pi. And whenever they do this, I don't think I've ever seen the time where they want you to use 2 pi. So you're going to have a parenthesis around that and a bracket around the 0. So use the 0, but not the 2 pi. It's the safest way. Yes?
What about if they find all answers?
If they ask you to find all answers, you shouldn't be listing just that answer. Do you remember the ones where it's all solutions? We should probably talk about one of those. Actually, that's going to be on your little quiz you're going to get in a little while. So I'll let you learn about it then. All solutions. If I say find all solutions in the directions, that's different than saying all the solutions between 0 and 2 pi, right? Because then it's limited to between 0 and 2 pi. But if I say find all the solutions, and one of your answers comes out to like pi over 6, then you want to list all of the things that are like pi over 6. And there's a lot of them. You just keep adding 2 pi to them. So you go plus 2 pi, but that would only give you the first one. When you add 2 pi, it only goes over once. You know how to finish it? Yep. Did you get that from the video that was played when I was gone? Some of you weren't listening to the video that they played while I was gone. And that was that was really the only new thing that you really needed to pick up in that video, was that when you find all solutions, you got to not just say the one answer that works, you have to say plus 2 pi n. That gives you all the solutions, because basically it keeps repeating. You take this and you keep adding 2 pi to it and add another 2 pi and add another 2 pi. Yes?
What if there are multiple solutions like pi over 6 and 5 pi?
Okay, 5 pi over 6 plus 2 pi n, where n can be any number, positive or negative. So that would give you another set of answers that's infinite. Yep. Yep. So if you had 2 answers there, just when you say all solutions, just add 2 pi n. All right. Find all solutions would be what the directions would be on this kind. Find all solutions. All right, let's move on. Let's go to some other factoring kinds that you need to know. If I have sine theta cosine theta equals cosine theta, then you got to know how to set this equal to 0 and then factor it. Do it. See if you can handle it. All right, here's what you should have done here. Sine theta cosine theta minus cosine theta equals 0. That's the first thing. Always set it equal to 0 if you're trying to solve. Then you can factor out the cosine theta. And you'd have sine theta minus 1. And then you'd set this equal to 0, set that equal to 0, etc. Any questions on that kind? All right, so you'd have multiple answers that work. Cosine is 0 wherever x is 0. Where is x 0? Here and here. So you'd have 2 answers for this one, pi over 2 and 3 pi over 2. And then over this other one, it's sine theta equals 1. And then when is sine equal to 1? When y is 1. Where is y 1? Y is only 1 in one spot right there, and it's pi over 2. So pi over 2, and 3 pi over 2. Do you have to list pi over 2 twice? No, you don't. It's the same exact answer. You don't have to list it twice. All right, let's do another kind of factoring. There's one just like this on your homework. Actually, sorry, cosine. This is supposed to be cosine. Let's do minus. Just plain cosine. There we go. Okay. And I messed something up. I'm sorry. There's a minus on top. Otherwise, you can't factor the top. I meant for this to be a factoring problem. There we go. Okay, the really common mistake here is to just look at it and say, oh, I can cancel these. So they were down to just cosine or sine minus cosine. Wrong. That doesn't work. I told you to factor it. It should be a healthy hint, because the bottom can't be factored, only the top can be. Do you get how there's something squared and they're being subtracted? It's just like x squared minus 16 we started with. It would factor into x plus 4 and x minus 4. Same thing. This would factor into sine plus cosine and sine minus cosine. All over what's on the bottom. Sine minus cosine. And then look, they're the same. That cancels that. Final answer, sine plus cosine. The most common mistake answer, sine minus cosine. Because they think, oh, this will just cancel this and everything's negative, so the answer must be negative. Nope. Once you factor this guy out, you see one of them has a plus in it and one of them has a minus in it. And it's the minus one that cancels. Final answer would be sine theta plus cosine theta. All right, another kind of factoring one. Should be good at factoring for this test. 2 sine squared theta plus 3 sine theta plus 1 equals 0. Factor that one. Go ahead and finish this one all the way out. There's going to be several right answers, like pi over 2 and pi and 3 pi over 2 and that kind of stuff. I'm going to pause for a second while you work on that. Okay, I'm going to keep moving for the interest of time. This one factors to 2 sine theta plus 1 and sine theta plus 1. First, outside, inside, last, what I'm checking. That's 2 sine squared. Outside is 2 sine theta, another 1 inside, so it makes a total of 3 sine theta. And the last is 1. Yay, it worked. Okay, then I would set each side equal to 0. I'm just going to save myself a teeny bit of time by saying equals 0 right here. Then I'm going to subtract 1. 2 sine theta equals negative 1. Sine theta equals negative a half. Raise your hand if you got to the same place as me. Okay, good. And then this other side, sine theta equals 0, sorry, negative 1. And so then this is like saying sine is y, right? So like y is negative 1. There's only one spot where y is negative 1, isn't there? Where's y negative 1? It's down there. That spot, right? And that's 3 pi over 2. Is there a tangent in here I should be worried about crashing? No. But what are the two things that could crash tangent? Pi over 2 and 3 pi over 2. So that is worthy of thinking about. Is there a tangent here that might crash? No. All right. And if it had, it wouldn't make the whole problem null and void. It would just cross off that answer as extraneous. But, all right, so that worked. To this other side, where is sine negative a half? Well, where is sine negative? First of all students take calc. All of them are positive, so it can't be here. We want sine to be negative. And sine's positive here, so it can't be here. So I'd need 1 here, and that's for sine is opposite over hypotenuse. Here's opposite, here's hypotenuse, and this is a negative, and that makes it all make sense. And then this is across from the 30, and the answer isn't 30 though. It's in radians, and this would be a bunch of pi over 6s. And specifically, this would be, all the way it'd be 12 pi over 6, but we want one less than that. 11 pi over 6. Get how I did that? There's another one. I'm not done yet. That's one of my answers. My other answer is down here. And that's negative 1, and that's 2. And then that makes that 30 degrees. But we really want all the way to here. And so if these are pi over 6s, this is 6 pi over 6 to there. Go a little further, 7 pi over 6. 7 pi over 6. 1, 2, 3 answers for that one. Raise your hand if you had that one right. Okay, awesome. Let's move on. Factoring, one more kind of factoring. I said factoring, which should help you. I know some of you are thinking, should I like replace 1 minus cosine with like sine or something? Nope. Factor it. Even though it's written backwards, you can factor that. Okay, what does it factor to? It factors to 1 minus cosine and 1 plus cosine. Raise your hand if you had that right. All right, some of you missed that one. That was an easy one. And once you've got it, do you see how the 1 plus cosines will cancel and makes it really easy? Do you get how that top factored? It's just like if I had 4 minus x squared. Could I factor that? Yup. 2 plus x, 2 minus x. Get what I'm doing here? Two perfect squares being subtracted. The square root of this one goes here, the square root of that one goes here, and one's plus and one's minus. Just like if the easiest one of all, x plus 4 and x minus 4. It's just like that. So it's 1 minus cosine squared, factors into 1 minus cosine and 1 plus cosine. This one's a square root of this one, and this is the square root of that one. Then at the end, that cancels that. All right, moving on. So many kinds of problems to know. I think we're going to try some of those. I asked you to get that worksheet out. If you have it out, I'd appreciate it. At the top, you're going to find a few like things you have to know. Like, for instance, sine of 2 theta. There's only one thing you can put in for that one. All over cosine theta. So if you know what sine of 2 theta is, you just look it up on the sheet instead of having to memorize it. And then you would do the replacement deal. Take this out, put in the other thing that it's equal to, do some canceling, and that's all there is to it. This would be an R2 level question, of course. Pretty easy. Yes? You get those double angle identities on a sheet for the test, yes. And you'll get those also. So all the ones that are in the top of the page with the box around them, all those the ones in the box are ones that are going to be given to you. All right, so what is sine of 2 theta? It is 2 sine theta cosine theta. So then this will cancel this, and the answer is 2 sine theta. Any questions on that one? All right, that was a super easy one. Now let's do one with the cosine double angle in it. And let's make this 1 minus 2 sine squared theta and cosine of 2 theta. Let's see if I can handle that one. You can use your sheet for this one, because cosine of 2 theta is not one you have memorized. But it's on the sheet. There's a really quick, easy answer that is wrong. Cosine of 2 theta. When you're picking, there's 3 things cosine of 2 theta could be. You want the thing that looks most like what you have. What you have, it's got a cosine squared in it, so, or sorry, sine squared in it. Uh-oh, I made a little mistakey poo. No, wait. Let me think. Could I do this? Oh, yeah, this is an easy one. I'm sorry, I meant to make it hard, and I actually made it easy. Okay. Cosine of 2 theta it's equal to 1 minus 2 sine squared theta, isn't it? So I can just do that, and they will just cancel, and it is just 1. What I was trying to do, just so you know, if it was this way, that's what I was trying to do. What if it's backwards? Then the answer is not 1. If it's exactly backwards, do you get how I could make it go forwards? How do you make something go be the opposite of the way it is? Factor out a -1. If I take this guy right here and factor out a -1, I'll have -1 on the outside, and then I'll have, you can reverse it and make it backwards. 1 minus 2 sine squared theta. And now it matches up with the top, so now it can cancel. Do you get how the answer is 1 over -1? So the answer is therefore -1. It's like this. Here's a simple one. X plus 2 over 2 plus x. Can those cancel? Oh, come on. Can those cancel? Your brain is so burned with really hard precalc. x plus 2 over, can't the bottom just be x plus 2? Aren't they the exact same thing? Can they cancel? Okay, now, how about this with minuses? X minus 2 and 2 minus x, are they the exact same thing? No. So they could kind of cancel, though, because they could cancel and leave an answer of what? Negative 1. Because on the bottom, you could factor out a negative and then reverse them. And now you effectively have x minus 2 right here, see? And now these can cancel, and you'll have an answer of 1 over negative 1 versus negative 1. All right, let's move on. That's not like a huge important point. It's a point. Okay, let's see. Judging by how much time we have left, this is the part where I'm going to give you a few practice problems. I'm warning you, these are like hard R3s, so you're going to struggle with them a little bit, and that's okay. And I don't want you to leave here all depressed, because these are like the hardest of the hard ones. You'll live if you don't get these right. Okay? I would hope as a goal for you and a partner, yes, you should do this with a partner, this little quiz, I want you to I can hope that you get 2 out of 4 of these right. That's a lot like the test you take tomorrow, because if you get 2 out of 4 of your R3s right, and you did well enough on your R2s, you're going to get a B. All you have to get is 2 out of the 4 R3s. All right, I'm going to pause this for a second, and then I'll restart it at the very end. Good. All right, take a look at the problems that you just tried. Number 1 is this one. Your first job is to factor it. Please don't talk now. This is a long, stressful day, and I don't have that much patience left, so be good. 2 cosine theta minus 1, and then cosine theta plus 2. Then this one turns into equals 0, so I go 2 cosine theta equals 1, cosine theta equals a half. Did you get 2 answers for that one? They should have been pi over 3 and 5 pi over 3. Raise your hand if you agreed with that one. Okay, good. Then moving on to the next part. This part is unusual because you have cosine of theta equaling negative 2. Can that be possible? No, cosine doesn't go that low. What's the lowest cosine goes? Negative 1. So this part has no solution. Just for that part. Okay, that doesn't mean the whole thing has no solution. Just means that part has no solution. So these 2 things would make the equation equal 0. Therefore, those 2 things are your answer. All right, let's move on to number 2. Oh, question?
All solutions.
What? Oh, it was all solutions. I did that last hour too. I forgot. The directions say find all solutions. So plus 2 pi n. You are correct. 2 pi n.
Pi over 3 plus pi n.
Pi over 3 plus... I don't want to go there. I don't know if that would work or not. Okay. So this one, I'm going to factor out... Oh, wait. First, got to move this over to the other side. Set it equal to 0. Tangent theta times cosine squared theta minus tangent theta equals 0. Now it's set to 0. Now I can start. Now I factor out the tangent. Tangent theta times cosine squared theta minus 1. Then I set this part equal to 0. Tangent of theta equals 0. Can tangent be 0? Well, let's check. 0 over 1 is like, tangent is like y over x. Do you remember that? We want a spot where y is 0 and x is 1. This is the only spot where x is 1. Is y 0 at that spot? Yeah, it happens to work out. There we go. That's it. So I should say 2 pi. True or false? False. I should say 0, not 2 pi. Because usually in the directions on these, and yep, there it is. In the directions on this one, it said answers between 0 and 2 pi where there's a parenthesis around the 2 pi. So it should not be 2 pi. Okay, so 0 is a good answer. Raise your hand if your group had a 0 for an answer. Okay, good. Then the other one. The other side is, watch close on this one now. Cosine squared theta equals 1. Square root, absolute value of cosine theta equals 1. How many of you knew that? Good. Then you need to break it into 2 parts. Cosine theta equals 1 and cosine theta equals negative 1. The only difference between those two is that little negative right there. Then I get two answers. Where is cosine, which is x? Where is x equal to 1? There's only one spot, and it's right there. And so there's 0 again. We already had that answer, but now we have it again. Do you have to list it twice? No. All right, then this other one, cosine is -1. That's like saying x is -1. Is there any more than one spot where x is -1? Nope, x is -1, only right there, isn't it? Okay, so that's also pi. So I had 0 before, and now I have an answer of pi. Final answer is 0 and pi. Raise your hand if your group had it right. Okay, questions?
For the other side, why couldn't also be 0 and pi for that on the left? Because
Over here? Okay, let me think. Could tangent is y over x. Tangent be 0 if it was 0 over -1. You've got a good point. Let me think. Is there any spot where x is -1 and y is 0? Yeah, this spot works also. Well, anyway, I got the pi just out of luck from the other side. So yeah, I should have said pi before, but pi is already on my list. So 0 and pi is the answer for both parts. So it's 0 and pi. Thank you. Good catch. Yes? Any other questions? Yes? Why it could work? Because if you want y to be 0, does it really matter what's on the bottom? Do you get how it doesn't matter? 0 divided by 1 or 0 divided by -1? It's 0 either way. I didn't think about it either, but it does not matter what would be on the bottom, except you don't want 0 on the bottom, but yes. Well, does it crash it? You're right to ask that question because there's what involved? Tangent. If there's tangent involved, you should ask the question, is this thing going to crash? What are the things that crash tangent again? There's tangent, pi over 2, and negative pi over 2, which is also known as 3 pi over 2. Did I give pi over 2 or 3 pi over 2 as answers? No. So I don't have to worry about it. All right, let's move on to problem 3. Questions? All right, number 3. Cosecant, would you agree you can write that as 1 over sine? How many of your groups figured out that that's how you should start? Good. If I could bless you with one thing for tomorrow, it would be factoring. If I could bless you with a second thing, it would be knowing how to do common denominators. All right, in this case, the common denominator wasn't too hard because as soon as you change that to 1 over sine, they have a common denominator. And then it's the one with the coat. Do you recognize that one? What is the one with the coat? It's cozy. So now it's cozy over sine. Cozy squared, I mean. Over sine. Then that was the tricky one. Who figured out what the answer was? One group? All right. So you can do this. You can do this. It's not that hard. It's not impossible by any means. You thought that was the answer. It was not the answer. All right. So what is sine equal to? 1 over cosecant. So if I have cosecant squared over 1 over cosecant squared, not squared, sorry, the bottom one's not squared. There we go. See, sine is 1 over cosecant. See what I mean? Then you can flip and multiply it. And when you flip and multiply it, you'll have cosecant squared over 1 times cosecant x over 1, and that makes cosecant cubed. That's fine. Did you get cosecant cubed? It's cosecant cubed. I won't talk to you about that right now. Okay, I don't want to confuse people with the wrong answer. All right, are there any other questions? All right, I warned you. Those would not be easy ones, but how many of you got them all right? Raise your hand if you did. How many groups got them all right? How about got 2 out of 3? All right, see, then in theory, you got a B on that one. You got to make sure you do well enough on the R2s, though, to qualify for that, you know. All right, we only have a minute left, so have a great day. Yes, I'm going to pause for a second in case there's a good question. Okay, and that's all I got for the video for today.